Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. When we look at a desert, we see a landscape of beautiful, shifting chaos. The dunes appear to move at the whim of the wind, unpredictable and silent. But to a mathematician, the desert is a living laboratory of fluid dynamics and geometry. There is a rigorous logic to how a dune forms, how it travels, and how it eventually stabilizes. Surprisingly, this same mathematical framework is beginning to change how historians and sociologists understand the rise and fall of human civilizations. We call this the parabolic nomad theory, the idea that the movement of empires follows the same nonlinear equations as the migration of sand. To understand this, we first have to look at the barchan dune. These are the crescent-shaped dunes that march across the desert floor. They move because of a process called saltation. Wind picks up individual grains of sand, bounces them along the windward slope, and drops them over the crest onto the sheltered slip face. In isolation, a single grain of sand moves randomly. But in aggregate, the grains form a coherent, self-organizing structure that can travel miles across a continent without losing its shape. This is the exact mathematical signature of a migrating population. In the early days of the Silk Road, or the expansion of the Mongol Empire, historians often focused on individual leaders. But when you apply the physics of saltation, you see a different story. You see social saltation, small groups of individuals moving under the wind of economic or environmental pressure. Much like sand grains, these individuals move in short bursts, but their collective momentum creates a social wave that flows toward resources. The shape of the expansion often mirrors the parabolic or transverse patterns of dunes, moving fastest where the terrain of resistance is lowest and the supply of people is highest. But the most chilling parallel between dunes and empires lies in the angle of repose. In granular physics, the angle of repose is the steepest angle at which a pile of material remains stable. If you add one single grain of sand beyond this critical threshold, the entire slope collapses in an avalanche. It is a moment of sudden, catastrophic phase transition. Empires throughout history, from the Roman to the Ottoman, have reached their own socio-political angle of repose. They expand until their administrative and military slopes become too steep to maintain. At that point, a minor internal revolt or a small external shock acts as that final grain of sand, triggering a systemic collapse that flows downward with the same mathematical predictability as a sandslide. Furthermore, consider the starvation of a dune. A sand dune stays healthy and mobile as long as there is a steady supply of sand entering the system. If the wind changes or a barrier blocks the flow, the dune begins to erode and eventually vanishes. This mirrors the resource starvation that ends an empire's migration. When the flow of wealth, gold, or labor is interrupted by a shift in trade routes, much like a shift in wind direction, the imperial structure doesn't just stop, it deconstructs. The parabolic shape that once projected power forward begins to flatten, losing its directional energy and dissolving back into the landscape. Mathematical modeling of these transitions allows us to treat human history not as a series of accidents, but as a predictable flow of human fluid across a geographic plane. By using the Navier-Stokes equations, which describe the motion of fluid substances, researchers are now mapping historical migrations to see if they fit the patterns of transverse or longitudinal dunes. The results are startlingly accurate. The way the Roman frontier pulsed back and forth across the Rhine behaves remarkably like a standing wave in a desert corridor. We are beginning to see that humans, despite our agency and our dreams, are often subject to the same laws of physics that govern a pile of dust. The parabolic nomad theory suggests that if we want to predict where the next great migration will occur, or which modern empire is nearing its angle of repose, we shouldn't just look at politics, we should look at the sand. We are part of a grand, geometric dance, a shift of weight and pressure that has been playing out since the first grain of sand moved across the earth. History isn't just written in books, it's written in the very geometry of the ground beneath our feet. For more incredible facts like this, don't forget to subscribe and turn on notifications.